All right, good morning, everyone. How are y'all doing? Good, thumbs up. So welcome to Math 1314 College Algebra. First thing I want to say is we just barely made this class. We didn't have quite enough people, but they let it go anyway. So I think we're all pretty lucky that the class didn't get canceled this past week. So that's a good thing. My name is Robert DiGiovanni, as you can see on my Zoom thing here. So I'm going to be the instructor for the class. I've been teaching at Northwest Vista for almost 2 decades now, since early 2000s. So this is my full-time job. And so just to let you know, I will be available to you not only during my office hours, but at other times if you need me, you can reach me. But we'll get to that in a moment. You can see here I put, how to earn bonus in the class. So one of the most difficult challenges that we have with Zoom is it's not like a classroom, right? So it's just a very different feel. We've all been doing it for what, over a year now. And some people love this because you can just sit in your house and then be done and go on with your life. But there are a lot of people who also miss that personal interaction. And there's nothing worse than just looking at names on a screen as opposed to seeing you sitting there. And so anyways, I can't require you to have your video on, but I'm offering bonus. So you don't have to have your camera on the entire time, just a majority of the time, have your camera on. And that way I can kind of start to put faces and names together. And it's just a much better experience. I don't know about for you, but for me, it's a much better experience when I can look up and see people. I have 4 monitors in front of me. So one of them is just my students. Then I have a screen that I'm going to be writing on. Okay, that's this. And then I have my roster and all this other stuff. So for me, looking up and seeing you is a good thing. All right. For you, you probably just see what I'm writing on, little picture or a little window of me or something, or the rest of the class. So, all right, let's get into this. We are doing College Algebra 1314. So just to give you a real quick little history on college algebra normally back in the early 2000s was just one class that everybody had to take. It was basically the minimum math requirement to earn a degree, any degree in college. Okay, so you had this thing called college algebra. And I'm trying not to bore you here, but I think it's important for you to understand the class you're in. All right, so there was this college algebra, everybody had to take it, and that was it, right? Kind of like you have to do what are other requirements? You have to do like English and some other things, right? There's history or government or whatever, all these core courses that everyone has to take. Well, what was happening was we were getting students coming to take college algebra and they weren't able to pass it. And that means they weren't able to get a degree. So this college, Northwest Vista, decided to split college algebra into 2 different college algebras, 1314 and 1414. Okay, so what this is 1414 is if you're going on to do more math. So if you need to do pre-cal, maybe you need the calculus sequence, you need some other courses that require more math, then you take the 1414. If you require no more math after this, that's 1314. That's where you are, okay? So we just need to be clear that when we start that you're taking a watered down version of college algebra. It has literally been made easier for you so that you can get through and continue on with your degree, all right? And not just quit school because the math got too hard, all right? Now, it's important though that you understand that this credit, 1314, if you were to go to UTSA, okay, or UT Austin or transfer to another college, they would take this 1314 credit as if you took the 1414. So you could take this credit and then go take pre-cal and calculus and all that. But here's the catch. You wouldn't be ready for it, okay? Because this 1314 does not prepare you for the future math classes you would need. So if there's anybody in here that knows that they need more math in this, pre-calculus and so on, then now would be the time for you to probably exit the Zoom session and contact the math department and say, hey, look, I need to take more math. I think I'm in the wrong math class. Is there anyone who has a question about that or is concerned about that? We're okay? All right, so if you change your mind, just leave the meeting, send me an email, say, hey, I left because, you know, I think I'm in the wrong math class, and I'll help you get into one if that's the case. So the good news then is that this class has been made so that you should be able to get through it. I'll give you a little interesting fact. At Northwest Vista College, the students that come in during the fall, on average, what do you think their math level is? Anyone have a guess? What math level do you think they're at? Let's go from kindergarten up to 12th grade, which would be high school senior. What level do y'all think? Anyone have a guess? On average, the student coming in from high school.
High school senior?
High school senior. You think the average student is about high school senior level?
Oh dear.
I would say like
Everything
maybe
just froze.
like 8th grade,
8th grade,
9th grade.
5th grade.
Well, I started at elementary.
Yeah. So the reason I'm saying this, it's not to, I think it's a failure of the education system from elementary school, middle school, up through high school. And I have my own personal opinions on this. It's not the fault of the student, it's the fault of the system. The system basically allows students to go through without actually requiring that they are actually a high school math level. So one of the biggest challenges that we have here in the math department is that we're trying to take our average 5th, 6th grade math level student to a college level math class, and we only have one semester to do it, right? The state has actually done away with a lot of our developmental education that we used to be able to take a student and offer them 4 classes to get them ready for college algebra. The state said that's too expensive, so they got rid of it. So it's a huge hurdle. And so in this class, you're going to see it, okay? Because during my lectures, I'm going to call on you. I have a nice little list over here. I'll show you my list. Okay, here's my list of the students in the class. There's only 16 of you, all right? And I'm going to be calling on, you'll probably be called on every single day, all right? And I'm going to ask you to respond. I'm going to be putting something up here and saying, hey, now what would you do next? Or, you know, I'm just going to be calling just like I would in a regular classroom. And I expect for you to respond. And if you don't know, you don't know, whatever. But what you're going to see is that everyone in this class is at a different level. Okay, everybody is. So this is, I'm never trying to embarrass you or make you feel bad. It's just, you know, everyone's going to be a different place. So you may be someone that I call on you and you're like really nervous because your math level is weaker than others, or you may be really strong. You may be getting frustrated because other people don't understand. It's just the nature of the beast here. Okay, everyone here is all over the place in the math in terms of math. Okay, so be sensitive to that. All right, we're not here to humiliate anyone. We're here to learn, and I believe that if you put in the work, everybody in this class can get through this with an A or a B. You just have to put in the time. Okay. All right, any questions? I'm going to get into the syllabus. I want to go briefly through the syllabus because we could spend the next hour on that. We're going to be here from 11 to 1:40. That's a long time to be sitting here listening to somebody, isn't it? That's a long time. So we will take a break. We'll try to do a break around 12:15 every day. We'll do a 10-minute break, unless y'all get to the point where you're like, let's not do a break and we'll end 10 minutes early or something like that. We'll see how it goes, all right? Because it's, you know, during a normal semester where we're on campus, we usually do the 10-minute break and everyone walks and goes get a drink or whatever. Here, we just may want to grind through and just end the class early. Any questions? Okay, so let me bring up the course. Give me a moment here. Okay, so I'm hoping everyone's been able to get into the Canvas page, right? If anyone has not been able to get here, you can talk to me later. This is our main page to where all of the information for the course is located. And if you're in the Zoom session,
You are super digital, sir.
I
I don't know if it's just me or what, but
am I pixelating for everyone? I think it might just be you, Cheyenne.
Yeah, it looks okay for me.
Yeah. Yeah, because you looked frozen there for a moment, Cheyenne. Okay, so does anyone have any questions on how to get to our main Canvas page? No? Okay, so here, I will let you read through this. The main idea here is that I'm going to be recording all these sessions, okay? I will put them on YouTube later, all right? So everything that's recorded on my screen here will be put on, the video will be put on YouTube, and you can get to that through the Zoom meeting recordings, right? So if you ever need to go back and watch something, or if you miss class or something like that, go back and watch it. Here it is. Now, the materials for the class is this class packet. So you click on that and you download it. So you don't have to buy anything for this class except for a calculator if you don't have one. All right, so this packet, I already have it here. Let me show it to you. This packet, you don't need to print it. You can buy it from the bookstore. It's, I think, like, did anyone buy it by chance and have a copy of it or not?
From the bookstore, I actually don't know if you have to pay for it. I found an email in my email and it actually told me that the bookstore had something ready for pickup for me, and it ended up being the book you're talking about.
That's right. I think that you can just drive by and pick it up or something, right? You may have received an email about that. So it might even be free, but it's electronic. You can have it here. And this is what I'm going to be using to, to deliver the material for the course. Now there's pros and cons to this. The pro is it is cheap or even no cost. The con is that it was not written in this with the sense of like a textbook where you could go through and see like examples worked out, and it's just like problems and ideas. So I'm going to go through this packet. I will cut things out that I don't like. I'll put my own things in, but it's not really like a real textbook, so I think it's good, but everyone has their own opinions on this, and it might have mistakes. They're looking for mistakes, but it was written last year. Okay, it was revised, so we are going to be covering this. So it has a table of contents right here and page numbers, and so when we look at our schedule for the class, that's here. When we look at that schedule, you know what, I don't even need to do that. I'll just show it to you this way. Here's our schedule. The schedule shows the day, like today is Monday, June 7th, and we are going to cover everything here in gray. And then these are where your homework assignments are. And that's all based on that packet. All right, so I'm going to cover these sections. I think it's 3 sections I'm going to cover today. And then there will be, I believe, 3 homework assignments. I'm going to cover 2 sections today. And then there will be 2 homework assignments that go with that. And then the next class will cover 2 or 3 sections, and then there's homework assignments. So these homework assignments are referring to the packet. And I'll show you that when we look at the packet here in a minute. And look at this, we have our first exam a week from today. So next Monday, we have our first exam. And we are going to have our exam, and then we are going to finish the exam. We're going to continue. I'm going to lecture more, talk about more sections after the exam. So we don't take the entire time for the exam in this class. We do half exam and then continue with more material. So that's going to kind of suck, but we can't afford to just use an entire day for a test. This first exam, I know it's coming right around the corner, but it's only going to have a limited number of sections, and a lot of this will be hopefully review for you, things you've seen before. And then we just kind of crank through this. We have another exam on June 28th, and then let's see, we have a July 4th holiday. So the Monday after July 4th is a holiday. We don't have class. And then we have another exam and then we get down to a fourth exam and then the final. This fourth exam, I don't know how this is going to go. We may just not even do the fourth exam, depending on how much time we need, because it's the day before the final. So it's like you're going to be taking an exam, and then I'm supposed to talk about some material and then taking an exam the next day. So we'll see about exam 4. All right, any questions right now? Let me get back to that main page, because this is where like everything is, right? Our recordings, the packet, the schedule. I also have some videos here that you can look at of old classes I've taught, 13, 14. You don't need those, but it's here if you want to go look at it. And then files takes you to, basically where everything is. All those links, this is if you want to get to all of them in one place, here's whatever. I also have some exam reviews and solutions. Let's see what this has in it. These are some older exams. Now, these are in the summer of 18. So these are a little bit older. I will provide you with a review for each exam. All right. Every exam, I'm going to give you a review, and I will provide you the solutions to the exam also, or to the review. All emails must be done through this system. Don't email me from your Gmail or Yahoo account. Always email me using the Canvas, because if you try and send it through something else, it will get filtered out and I won't get it. So just go here. I'm sure you can figure out how to use this inbox to compose a message. And then anything I need to send to you will also be done that way. Questions? All right, now the fun part. How are we going to do our exams? Right? This is the tricky part. So I have a picture of myself. Look, I'm wearing the same shirt. Okay. This is a picture of me in my office here. And what you're going to have to do for the exam, and this is in the syllabus, okay? What you're going to have to do for the exam is you are going to have to be live on camera in Zoom taking the test. And your camera has to be set up so that I can see you. So you notice you can see me, and you can see my workspace. I have to be able to see all of that. I can't just, like right now, those of you who are on camera, that would not be okay for a test. I need, most of the time I have students use their cell phones, and they log into Zoom and they join the meeting, and then they set up their phones somewhere to the side of them so I can see kind of from the back a little bit, the like side of you and then what's in front of you. All right. That has to be that way, or you can't take the test. Anyone who can't get their camera set up properly is kicked out of the test. So it might be a good idea for us to practice with that. Not today, maybe next class. All right. So do what you need to do, install Zoom on your phone, or get ready to move your laptop around. Next class will take about 5-10 minutes to see if everyone get their camera set up properly. So what I will do on the exam days, we'll come into Zoom and I will email everybody the test through Canvas. So you'll be on your computer, you'll download the test, and then you have to actually hand write all the problems from the test on a piece of paper. Okay, so you'll hand write all the problems. If you have a printer, you can print it, that's fine. You'll hand write all the problems, and then I will officially start the test. And at that point, you can't really be on the computer anymore. You just have to have your camera set up, and then you take the test by hand, on pencil and paper, on your own paper, on your own blank paper. Does that make sense? Now, after you're done taking the test, you will have to submit your work to me. So what you'll do is most of you, if you don't have a scanner, most of you will just take your phone and you'll take pictures. So once you finish the exam, you will tell me you're finished. You'll do a chat on Zoom. You'll say, hey, I'm done. And then you can leave the test. You can log out of Zoom. You've got 15 minutes from that time to take pictures of your work. And then you take pictures, and then what you have to do is send those pictures to me. All right. Does that make sense or not? I know this is a little confusing. This sucks. It's the way Zoom is. But you'll send that work to me. And then what I'll do is I'll grade it, and then I'll send you back a file that has your graded work. Any questions?
Can we send it to you by email?
What, okay, yeah, so I want to make sure y'all follow first. Now I've got one more detail that's going to throw a wrench into things. When you take these pictures, right, let's say you have like 5 pages worth of work, right? You're going to have 5 pictures. What you have to do is you have to convert all 5 pictures into a single, what's called PDF file. PDF is Adobe. So that, let me show you here. I need a PDF file. If you're using an iPhone, I think most iPhones have an automatic, it'll turn your pictures into a PDF. If not, there's an app called Cam Scanner. Cam Scanner.
For iPhones, if you just go through the note message, the little notes thing, and then you click, there's a little camera icon, you click it and it'll give you the option to scan.
Okay. So you're gonna, yeah, whatever you use, whether it be the note, I see, I don't have an iPhone, or else I'd be able to speak to it a little bit more, but I know you can do that in note with the note feature of the iPhone, but I've also known students who couldn't do it on their iPhone. Maybe it was an older version, older operating system, I don't know. But Cam Scanner is an app that I know students have used for an iPhone that works, and it converts your pictures into a single PDF. And then what I'm going to do is I'm going to send you a link in an email to a Dropbox where you click on it and it says upload your file. And so you'll upload that single PDF file to me. All right. Now I want to show you an example of this, okay? Just to show you what I expect to get from you. So I'm going to show you something from last semester. And I'm going to show you like a, oh wait. I'm going to show you my Cal 3 class. That way, none of this makes any sense. Okay, so they had to submit exams. Here we go. So there it is. So this student sent me their exam. Note it was a single file. Did y'all see that? It was a single file. It was about 2.5 meg. Single file. And it contains 6 pages. So it was 6 pictures. And you can see how neat this is, right? How clear and clean, and it's not blurry, right? This is what I expect. All right, because it makes it easy for me to grade. Because once I have it here, I can just, oh boy, I haven't used this in a long time. I can just like, write on it, and then I can make a copy of that and then send that back to you. And that way you know what you got right and wrong and where I took off points. Okay, but I need a single file. And just think about it. If everyone sent me their 6 pictures, right? I have 15 students, 16 students. That becomes a lot of files I have to organize, and it's just easier with one. So what we're going to do for tonight, I'm going to give you a homework assignment. And what I'm going to do is I'm going to send everyone a link in an email today. And it's going to be a link to a Dropbox for you to practice this. All right. So just take like 3 or 4 just random papers or something, or whatever you want to do. Just take pictures of several things, try and turn them into a single PDF file and upload it to me today. Or it'll be due by next class. All right. So you'll have a day or 2 to figure it out. And if you're having trouble, get in touch with me. All right. So it's very important that that happens, because if you don't send me a single PDF file for the test, then I won't take it. So it needs to be in that format. Questions? All right, so I said I was going to look at the syllabus. Yeah, I'm not going to read through this. I'm assuming you can all read, but one important thing in the syllabus is how to get in touch with me. So I give everybody my cell phone number. All my students in all my classes, I give them my cell phone number. All right. So if you're ever having trouble with something, you're working on a problem, you can't figure out what's going on, then just text me. All right. And what I ask is that you take a picture, like if you're working on a problem, you can't figure it out, take a picture of the problem, because I might be out, Home Depot or something, and you ask me, hey, I need help on number 4. I don't know what number 4 is, right? So take a picture of the problem, then take a picture of any work you've done, and I can try and help, see where maybe you went wrong, or, help guide you in some way. And on my phone, I can write on it because it's an Android, not an iPhone. And I can send, edit things, draw on it, whatever, and then send something back to you. So just know that I'm available to you. You can text me anytime. I don't have any, restrictions on when. Don't worry about disturbing me at night. I just silence my phone, so it's not a big deal. All right. Office hours, this is also very important. I have a Zoom session that I run, this Zoom session here, Monday, Wednesday, that's right before our class, for an hour before we meet. I'm in a different Zoom session, not this one, just follow this information right here. And that'll take you to my office hours, and I'm just in there for an hour, just sitting there, like watching YouTube videos, waiting for students to like come in and ask me a question. All right, and that's open to all my students. So if you're free during that time, please come in and get help if you need it. And then also on Tuesday, Thursday from 12 to 1. Now, I can be available more often, but those are like my committed times. If you want to meet with me, on a Friday or on Saturday or something like that, I can most of the time jump onto Zoom pretty easily if I'm at home. You just need to text me if you want to meet me, or email me and say, hey, are you available this Saturday at 1 or something like that? And I can do a special meeting with you if need be. Questions there? These two are the same. These two are the same meetings. Okay, for the Monday, Wednesday, and the Tuesday, Thursday, it's the same meeting, same password. I've already told you you need that packet, which you can download, right? Or go get from the bookstore. Check your email for that. And then, oh yeah, I'll get to that. You need a calculator. Now it says that you're supposed to have that calculator, but you don't need, I don't even know if I have mine with me right now, but you just need a calculator. Any calculator really will work, as long as it's scientific. So if it has a bunch of buttons on here that you don't know what the hell they do, then you have a scientific calculator, right? So as long as you have that, you're good. We say to get this one because if you don't have one, this one's like $12 or something, $12, $15 on Amazon or Walmart or something. So it's easy to get, and it does everything we need it to do in this class. Okay, questions there? Of course, you need a computer. You're on Zoom, but you probably need a phone also for the exams, because again, you've got to have a camera set up in a proper way. Now you can move your laptop if you have a laptop, or maybe if you have a webcam that you can move around, that'll be okay. You just can't during the test be like I am right here, right? Like I already said, that camera can't be in front of you like this. So as long as you can get it set up that or something, that's okay. Okay. I'm not going to go through the objectives. Talking about the grade. So one thing that kind of sucks about this is that your entire grade is going to be what you do on the exams. All right. All your homework that you do, right, that I assign to you that you're supposed to do. I mean, this is, at the end of the day, this still is a college level class. And so there's no collecting of homework and me grading homework. In fact, the packet itself that we looked at, that packet, if you go to the very end of the packet, it has all the solutions. Okay, where is it? Here we go. It has all the answers. Now it's to just the odd problems, but it has the answers. All right. So I'm not collecting homework for a grade, but what I will do is I will offer some sort of bonus to you where if you have your, let's do this, let's say this officially, okay? If you do your homework all semester, all right, and you keep it all together nice and neat, and then at the end of the semester, you submit me a single PDF file that has maybe not a picture of every page, but like just shows me that you have been consistent with your work, maybe 10 or 15 pictures, submit that as a file. I'll give you a bonus in the class for homework, right? Let's say it'll be 5% of the grade. So you theoretically add 5% here, you could get 105 in the class by just doing your homework, which you're supposed to do anyway, all right? And if this were a face-to-face class, I would tell you just keep a binder and then at the final you turn in that binder. But we can't do that. And I don't want you to take a picture of 100 pages of work. So we'll just say, 10 to 15 pages, give me pictures and that'll be okay. I want there to be some incentive to do the homework. But at the end of the day, it's a college level class and you should know, hopefully, at this point in your life, that to do well in math, you have to practice, you have to actually do it, right? So yeah, so we have our exams, there they are. Each exam is equally weighted. And the only exam here that's cumulative is the final. So the final, exam 1 will cover material we cover up to exam 1. Exam 2 will be stuff after exam 1. Exam 3 will be stuff after exam 2. Exam 4 will be stuff after exam 3. And then the final will be a blend of all of these. And again, I'll give you a review. So that'll give you some idea of what to expect for each exam. Questions? Okay, so in terms of attendance, like I showed you, I'm going to have my roster up here. And Zoom also keeps track of who was here, how long you were here, and so on and so forth. So I will take attendance, and then also I'm going to call on you. Like I said, probably every day you'll be called on. And so if I call on you and you don't respond, like I'm just like, Tiffany, are you there? Tiffany, 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 and there's no Tiffany answering, then I will count Tiffany as being absent, even though Tiffany is like in the Zoom session. If you don't respond, then I'm going to just assume that you logged in and that you're watching a movie upstairs, or you're in the backyard, playing with your dogs or something. You're not attending the class. All right.
No, I'm sorry. I just needed to go to the restroom.
Oh no, you're absent. Sorry, too late. No, it's okay. I wasn't really calling on you, Tiffany. But you get the point. Like if you step away, that's okay. It's a consistent thing, right? Like every time I call on Tiffany, she's never responding, right? So, and I understand this is hard. I mean, sitting here in front of a computer screen for as long as we're going to have to, I mean, I know it's hard. So that's why I'm saying, like, it's all right if you step away. It's all right if you turn your camera off for a little while. That's fine with me. All right, attendance. Okay, so I already talked about the exams, and this actually goes into detail about that, like how I'm going to send the exam. You have to take pictures, blah, 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 blah. I'll be recording you, single PDF file, all that stuff is here. Behavior, I have not had a problem. Oh, I did have a problem last semester. There was a girl who was smoking a joint and she didn't realize she was on camera. It was pretty funny. So yeah, I didn't do anything. I just kind of like, she realized it before I think the rest of the class did. It was pretty funny. But obviously there's certain things that I can't let go here in a class. So just, watch what you're wearing, watch what's in your background, just be careful with things because we're being recorded. So, all right, tutoring. So I told you that I'm available on office hours, but that may not work out for you. So there is, online Zoom tutoring. We have a tutoring lab that you can go to, and here's the link to it. And there's the hours of operation. So pretty much Monday through Thursday, from anywhere from 7 a.m. all the way to 9 p.m. You can just click on that link and it'll take you to a Zoom session. There will be a math tutor there. They're aware of the packet that you're working out of. They can help you with any problems you're having with the homework. So if you can't get in touch with me, just realize that's a backup plan. Okay. And I think the rest of this, I'll just let you read through. This is our calendar. And then there's other policies that the college has, but those are all administrative things. Does anybody have a question about you know, the basic idea of the class, how this is going to work. I'm really counting on all of you to participate. I'm going to be trying to do breakout rooms where I put you in a separate Zoom room with a couple of your classmates and give you problems to work on. You know, it's hard because most of you don't have the ability to write on a screen, but at least you can talk through problems together. I'm going to try and make this where it's not just me sitting here, blah, 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 the whole time. I don't want it to be that. So we'll try and incorporate some sort of group work, but you know, that's gonna count on you also participating. So, all right, we ready? I think it might be math time. See, we do the schedule, the packet, the syllabus. Yeah, we're ready. So as a reminder again, if you came in a little late or weren't here in the restroom or something, having your camera on consistently in this class will earn you half a point per day, which allows you to get up to 8 points added to the final exam grade. That's almost an entire letter grade, almost an entire letter grade curve by having your camera on. I hope that's good incentive. Okay. We're ready. I'm ready. So here's what I'm going to try and cover today. I've got 2 hours. I'm going to try and cover fractions, okay? Fractions and applications of fractions, order of operations, solving linear equations and linear expressions. And then we may or may not get to this. This actually was not on the schedule for today. I thought it was, but I already made my first mistake. So maybe, I'm going to say question mark, but I'm thinking no because it's already 11:40. So, so your homework for tonight will just be off of these 2 pages, 221 and 225. And then, you know, when I show you the packet, you'll see how the homework looks in the packet. So that's our goal. All right, fractions, and then this thing right here. And then your other homework assignment will be that I'm going to send you a Dropbox link for you to practice taking pictures PDF file. All right. I'll remind you at the end of class. Any last words before we dive in? How are y'all feeling? Come on, what's up? We got to make this somewhat fun somehow.
I'm just sleepy. I'm a night shift worker, so.
How many of you are taking other classes? Anyone else taking more than this summer? Yeah, you can raise your hand if you're on camera. No?
I'm taking microbiology in this.
This microbiology. That sounds fun, but I don't know. Is it on Zoom?
Yeah.
Yeah, I think we're gonna try. I mean, next semester, I think. I haven't heard the official word, but I think we're going to be back 100% at Northwest Vista in the fall. That's my bet. I think I think they said 75% for sure, but I'm thinking it will be 100 by the time we get there. So I don't know. I'm ready to go back. I'm going crazy. I'm trapped in my office. All right. How about work? Y'all working? Is anyone? How many of you work full time? Anyone work full time? Yeah. That's a lot to balance, right?
Excuse me, sir. I had a quick question real quick. What if there's a day that we have to leave class early, like we can't stay the full like 3 hours?
That's okay. Yeah, just let me know. I mean, it'd be nice if you just sent me a chat, said, hey, I have to go somewhere today, you know. That's fine.
Okay, so would we still be counted for attendance that day though?
No, I think what would be important is for you to send me something through the chat or an email saying, hey, you know, I had to leave class early today. Just so you know, in case I called on you and you didn't answer, you would have at least said something.
So just for like common courtesy, send like an email maybe.
I think that would be nice. That way I'm aware. I hate babysitting. I hate taking attendance like at all. Because this is college, right? So, I mean, like, I shouldn't have to sit here and be like, who's here, who's not here? But with Zoom, it's just so easy for people to just log in. And then, I mean, I do this, I'll admit it, like I have to go to meetings, you know, and I'll just go to the meeting and I'll just log in, but I'm really like at Home Depot, like shopping, you know, and I'm not, you know what I'm saying? I'm logged in, I've got an earpiece in, I'm listening to the meeting, but I'm not really there. I'm just trying to avoid that sort of thing because you're trying to learn, right? So it's hard to learn when you're just like listening to somebody talk and not really paying attention. So just trying to avoid that. That's all. That's why being on camera, you know, it helps. I think we will identify quickly if there's anyone in this class who's going to try and just act like they're here. I think we'll figure that out pretty quick. But you're also all taking a summer class, so you're somewhat a little more motivated than other people because a lot of people just take the summer off. Okay. Anything else? Did y'all get my email about the education majors? Are there any education majors here? Elementary education? No. I guess there's some money or something, some incentives that they're giving. All right, let's talk about fractions. So like I said, this packet, okay, this packet, I'm really interested. This packet, to me, the most interesting part of this is the homework assignments. Like that's what this offers to you, is the homework assignments. I'm not a big fan of the way things are presented. So you're going to see me skipping through a lot of things and just kind of picking out the pieces that I like. So I'm going to actually go to a new page right now and just start talking about fractions. All right. So fractions is the first topic we have, right? So this is going to be kind of like baby steps here. We all know what fractions are. We've seen them at least, but we'd like to have some sort of physical or geometrical representation of what a fraction is. All right, so the most common illustration of a fraction is like if you take a candy bar, right? And if we start with a single candy bar, then imagine cutting it up into pieces, equal pieces. So you could cut that into as many pieces as you want. You could have, you know, that's one piece, right? You could cut it into two pieces, right? Or you cut it in 3 or 4 or 5, however many you want. And then you can say, if you cut it into so many pieces, take just a certain number of those pieces. So let's cut this into, let's say, 4 pieces, right? And so everyone agree we have 4 equal pieces there? If I take, let's say, 3 of those, right? Then I have 3 out of the 4 pieces, and we represent that as a fraction as 3/4, right? So this is how many we take, and this is how many parts there were, right? So there were 4 parts, and we took 3 of them. That's the concept of a fraction. And I realize all of you, like, again, I'm not trying to insult you, all right? This is the basics of what a fraction is. So, but there's some little subtleties in this that can help explain things that maybe you haven't understood in the past. So, for example, let me start by writing the fraction first. What if I write the fraction 1/5? Okay, 1/5 is the way we'd say that. If we would now try and draw this, we start with a candy bar, right? We cut this into 5 equal pieces, right? Because the bottom is how many parts we have. And we're only going to take one of the parts. So that'd be 1/5, right? 1/5. Still, that's nothing new. But how about this? 3. So what does that look like? Like physically, if I were to draw that, what does the number 3 look like? So the first thing we have to realize, and this again goes back to your knowledge of numbers, is that any number can be written as itself over 1, right? So you could rewrite the number 3 as 3/1. So how many parts do we have? How many parts? Anybody? Remember, on a fraction, the parts is the bottom, the top is how much you take, right? So how many parts do we have here? Tiffany is saying 1, right? We have 1 part, right? So here it is. Let me draw the 1 part. There it is. And how many of them am I going to take? 3, right? So that means I need to take this whole thing, but I needed 3 of those. So I'm going to have 3 whole parts. That's 3 candy bars. Does that kind of make sense? You're taking 3 whole parts, which gives you the 3 full candy bars, and that's the number 3. As opposed to 1/5, which means you're going to cut this candy bar into 5 parts, take 1 of them. Here, cut the candy bar into 4 parts, take 3 of them. Now, here's where things I think get a little interesting. How about this? How about 0? Well, again, anytime you have a fraction, a number, you can write it over 1, right? So 0 is actually the number 0/1. So how many parts do you have? 1 part, right? You have 1 part. That's the bottom, the 1. And how much of it are you going to take? Nothing, right? So there's the candy bar, and you're not going to take any of it, which means you have nothing, right? You have nothing because you took nothing. So that's why 0 represents nothing, right? Doesn't matter. The fact that you had a candy bar here didn't matter because you didn't take anything. All right, let's do one more. This to me is the most interesting one. What about 1 divided by, oops, let me do it in red. What about 1 divided by 0? 1/0. Can somebody tell me what they've been told about this? Hopefully somebody has told you something about having the 0 on the bottom before.
It's not possible.
It's not possible. Hopefully you've been told in the past that you can never divide anything by 0. Does that sound like something you've heard before? Let's see why it kind of makes sense that, well, it kind of makes sense that this doesn't make sense, right? How many parts do you have? Well, according to this, how many parts do we have? None, right? We have no parts. There's no candy bars at all. And how many pieces are we supposed to take? 1. How can you possibly take 1 piece of nothing? So this is undefined. Because it's impossible to take 1 part from nothing. You can take 3 parts from 4, you can take 1 part of 5, you can take 3 parts of 1, you can take no parts of 1, but you can't take 1 part of nothing. So this is just another kind of way to look at fractions, and really my main goal was to get you to understand why division by 0 is not defined. Okay, so when you're in grade school, you're learning about numbers, right? When you're learning numbers in basic, grade school, you learn something called arithmetic. Right? And you're taught about numbers. And what are the 4 operations you're taught when it comes to numbers? What are the 4 basic operations? I'm not calling on anyone yet. I'm still letting y'all respond freely. But it's looking like I may need to call some people here. So what are the 4 operations you're taught?
That addition, subtraction.
Addition, subtraction,
Multiplication and division.
multiplication, and division. And when you first learn it, right? Those are the 4 symbols they use, isn't it? And then later on, don't we get rid of this multiplication symbol, right? And we start to use a dot instead, right? And then we do away with the division symbol, and instead we write fractions, right? We put something over something instead of division, the symbol. But in the beginning, when you're learning numbers, you're taught addition, subtraction, multiplication, and division. And you're taught those in that order, aren't you? Like first they introduce addition, like what's 3 plus 4, Johnny, right? Johnny tells teacher what 3 plus 4 is. And then they start doing subtraction, which gets a little more complicated. And then they do, multiplication, division, right? So kind of in that order. What we want to make sure you can do here today is, can you do those 4 operations with fractions? Because when it comes to fractions, it's actually more complicated to do those 4 operations. And when we do those 4 operations on fractions, we actually teach you in a different order. We teach you how to multiply fractions first, then how to divide them. So this is the first thing we learned. Then the second thing, then we teach the addition and subtraction. So when we're working with fractions, we do it in that order. And it's because it's easier. So let's see if you all know how to multiply fractions. So multiplying fractions. So can someone just tell me what they've learned in terms of fractions? If I have 2 fractions, how we multiply them together? So if I take, let's say, for example, 3/4, and I want you to multiply it times, let's say, 5/7.
You cross divide.
What do you mean?
You would take 3 times 7 and then 4 times 5.
Okay, I think what you're referring to is if there was an equal sign between them. If there was an equal sign, then you're doing like this thing called like cross multiplication. But here is just multiplying 2 fractions together.
Well, don't they need the same base to multiply? Or would we just multiply like 4 times 7 equals 28 and 3 times 5? Like,
yeah, okay, so we have a lot of different ideas here, don't we? I mean, just with this operation. One idea was this, like 3 times 7, 4 times 5. Another idea is what was the other idea? I already forgot. 4 times 7. Oh, you said you had to have the same, maybe.
yeah, like multiplying across the denominator and the numerator. Or I forget if you need the same number on the base for multiplying.
Okay, good. So there's confusion as to what's the right process, right? Like for some people, it's not clear. So with multiplication, all right, now I'm talking about multiplication only here. If you have 2 fractions, this is the easiest out of all of them. You just multiply straight across. Okay, so all we're going to do is multiply the 3 times the 5 and the 4 times the 7, and that will be what it's equal to. So if I do 3 times 5, I'm going to write it down. I'm doing 3 times 5, and then I'm doing 4 times 7, and that gives me 15 on top, and then 4 times 7 is 28. Now look, everybody here is going to be at a different place. I've already said that. For some people, I ask you, what's 3 times 5? And you're like, are you kidding me? Why are you asking me that? I know what 3 times 5 is. And for other people, I ask them what's 3 times 5, and they want to break their phone out, and they want to do 3 times 5 on their phone. Okay, because I don't know, that's just the way things are these days. I mean, it's just the reality of the world, right? I went to HEB a while back. I bought 2 balloons. They were $1.50 each. And the person behind the counter got their phone out to figure out what the cost would be. This is not a lie. There was no stickers on the balloons. Like they didn't have a thing to scan. So I told her, I said, they were $1.50 each. And so she got her phone out, and I thought she was going to look up the balloons on the HEB app. Nope, she was doing $1.50 plus $1.50 to get $5 or whatever it is, whatever $1.50 plus $1.50 is, right? So I understand, like, everyone's at a different place. So if you're at a place where you have to do 4 times 7 on a calculator, then you just better have your calculator right next to you. Okay, that way you can get this done, right? All right, so here we go. We have this answer. This is the answer. This is multiplication. So let's see if we can come up with like a formula for this. All right, so let me show you on the side here the formula. If you have a fraction a over b times c over d, then you multiply straight across. So you're just going to do a times c over b times d. So you don't have to worry about getting the same number down here. You just straight across, you're done. Okay. Now, what about division? What if I take that 3/4 And this time I divide it by 5/7.
I don't know if this is right, but this is the way that I was taught, is you like would flip the 5 and 7 and then when you want to divide, flip it and multiply across.
Yeah, so one of my students, like last semester or something, told me something. I think I had heard it in the past, but I think I'd forgotten it. This is what she said. Keep dot flip. Keep dot flip. That's how we do division of two fractions. So what it means is this: you're going to rewrite this. You're going to keep the 3/4 exactly what it is, 3/4. You're going to change the division into a dot, which is multiplication, but you have to flip the second fraction over. That's called the reciprocal. When we take a fraction and flip it, it's called the reciprocal of the fraction. So you're keeping this fraction the same. You're going to change that division into a dot, multiplication, and then you're going to flip this fraction over. And then you are just going to follow this, right, straight across. So 3 times 7, 21. 4 times 5, 20. 21/20. So as a formula, this is the way it would look. If you have a fraction a/b divided by c/d, this will be a/b, you keep it, you dot, multiply now, and then d/c. Okay. We all okay with this? Okay, I'm going to give you a couple more examples over here. How about this? Things can get a little weird, all right? Let's do, as another example, 2/5 times 10/7. All right, so we're going to go 2/5 times 10/7. So we can just multiply straight across, right? We can just go straight across because it's multiplication of fractions. That's the easiest out of all of them. We could do that, right? And that should be the right answer. So let's try that. 2 times 10 is 20, and 5 times 7 is 35. Now, although this is the correct answer, it is not what we call simplified or reduced, meaning there is some number that goes into both of these, that divides into both of these. So can somebody think of a number that goes into both 20 and 35?
5.
5? 5 goes into both of these, right? So when you do a reduction or reduce a fraction, what you have to do is you have to mentally come up with a number that goes into both 20 and 35. And I was told 5. So how many times does 5 go into 20?
4.
4 times. So if you take 20 and you divide it by 5, you get 4. So I can cancel this out and become a 4. Now, how many times does 5 go into 35?
7.
7 times. So that becomes a 7. So your reduced answer is 4/7. Okay, so you took the 35, divided by 5, and you get 7. So even though 20/35 is technically correct, it's not reduced. And so to reduce, you come up with 4/7. So in all the problems that I'm looking, or that I'm wanting you to do, I want you to reduce the fractions if possible. Get them down to what's called their lowest form. Now let's go back to the problems I did before. Could any of these be reduced? I didn't talk about it intentionally, but look at 15/28. Can you think of a number that goes into both of those? Is there one?
What number did you say?
Both of these. Is there a number, any number you can think of that goes into both 15 and 28? Other than 1. Because
No.
one goes in anything, right? 2 doesn't go into 15, right? 2 goes into 28 14 times, but 2 doesn't go into 15.
What about 3?
Okay, so 3 goes into 15. Does 3 go into 28?
Oh, well,
Try it, right? If you did 28 divided by 3 on your calculator, you get 9.333. So it doesn't go in evenly. Like it doesn't go in nice. right? Four doesn't go into 15. Five goes into 15, but it doesn't go into 28, right? So reducing is this process of trying to figure out if there's a number that goes into both. Now here, 21 over 20, same thing. There's no number that goes into both. It wasn't until I gave you this problem, 20 over 35, that you had this happen. Now I want to show you something back here on this step right here. When we were multiplying, you can also do the reducing here. So if you look at the 10 and the 5, what number goes into both of those?
5.
5, right? So you could say 5 goes into 10 twice and 5 goes into 5 once. So if I rewrite this as 2 over 1 times 2 over 7, and now multiply straight across, you would get your 4 over 7, which is the same answer. The moral of the story is that when you reduce a fraction, you can do it before the multiplication, or you can do it after the multiplication. Doesn't matter where you do it. We okay with that? Okay, let's try another one. How about this? How about 2 over 5 divided by 10 over 7? So I'm asking you to divide these instead of multiply them. So let's do the process for division, which is going to be keep dot flip. All right, so I'm going to keep it, dot it, flip it. And now multiply straight across. 14 over, let's see, 2 times 7 is 14, 5 times 10 is 50. Are there any numbers that go into both 14 and 50? They're both even numbers, aren't they? Right? They're both even numbers. So 2 should go into both of those. Let's see. 2 goes into this 7 times, and 2 goes into 50 25 times. So you should get 7 over 25. That's reduced. Now, looking back at the problem here, could I have simplified it here? So this is, be careful right here. Do you all see that right at this step right here, 2 goes into 2 once and 2 goes into 10 5 times? You'll see how I can get the 2 and the 10 to reduce? And then if you multiply across, you get 7 over 25. But you are not allowed to do the reducing before, while you're looking at the division. You cannot do it here. So you are not allowed to do, oh, well, 5 goes into 5 once, 5 goes into 10 twice. That does not work. You can only do that canceling out like that after you've done the keep dot flip. So be real careful with division not to do this prematurely. Are there questions there? Okay, I'm gonna give you, let's see, what time is it? 12:03. I'm gonna give you a couple of problems just to work on your own, just see how you deal with them. All right. So here we go. Just for yourself for practice. Let's do 5/3 times 9/12. 5/3 times 9/12. And then another problem, we'll just call this example 1, example 2. I want you to do 5/3 divided by 9/5. And then the third example, I want you to do 4 divided by 2/3. Okay, I'm going to give you all, let's say, 5 minutes. That's a lot of time, but let's see how you do. I want you to try and do these operations and simplify your answer if possible. And then I'm going to call on 3 different people. I'm gonna go 1 more minute. Okay, here we go. So today I think I'm just going to go kind of my own little random order here. Let's go with Diane. Diane, how's it going?
Well,
Doing okay? So did you do the first one?
yeah.
What'd you get?
5/4.
5/4. Okay, so can you tell me how you did it? Did you go multiply straight across first, or did you simplify first?
I simplified the 3 and the 9.
Okay, good. So Diane saw that 3 and 9, 3 goes into both of those. 3 goes into 3 once, 3 goes into 9 3 times. Is that what you did? Yes? Or no? Oh, you're cutting out.
Yeah.
Okay. And then did you
Yeah.
go straight across? Did you multiply straight across after that?
Yeah.
Okay, so now if you
About
multiply,
15/12 and then
good, 15/12. And then very important, then Diane realized that there's still a number that goes into both of those, right? And that's the number 3. So 3 goes into 15 5 times, and 3 goes into 12 4 times, right? And so you get 5/4. Good.
could I have simplified the 12 as well?
Yeah, so
before
another thing,
multiplying?
yeah, so here's another way you could have done this. You could have done the 5/3 times the 9/12. You could have done, this is 1 and this is 3, and then reduce this 3/12. 3 goes into 3 once, 3 goes into 12 4 times. Is that what you mean? Yes, you could have done that. So there's like all these different ways you can go about this. That's why I gave you that problem. It's a little bit, there's so many different paths. The important thing is that everybody gets to 5/4. Do I need to clarify that at all for anyone? Okay, let's look at example 2. Katrina, is Katrina here?
Yes,
Okay,
I
Katrina,
got 25/27.
25/27. Okay, so let's see, how did you do it?
I took the reciprocal of 9/5, so it's 5/9.
So you did keep dot flip like that.
And then I multiplied across.
Okay, and when you multiply across, you get that. And no numbers go into both 25 and 27?
I don't think so.
Yeah, so this is where things get a little weird. It's like you have to try, you have to like keep trying, but the question is like, when do you stop, right? Like when do you stop trying? Like 2 doesn't go into those, 3 doesn't go into both of those, 4 doesn't go, 5 goes into the top and not the bottom, 6. So when do you stop, right? You can always stop when you get halfway to one of the numbers. So 25 here, halfway would be about 12 or so. So as soon as you get to about 12, you can stop. But that is correct. 25/27. Good. All right, next. Jamal, is Jamal here? don't see Jamal. Okay, Deanna. Yeah.
Yes, it's
Hey,
Dina, actually.
What is it?
Dina.
Oh, Dina. Yeah, it's exactly the way it's spelled. I'm sorry.
It's okay.
Dina. Okay, Dina. Did you get the third one?
Yes, it's 6.
6. So how did you do it?
I flipped this 2/3 fraction, and then I
Okay.
multiplied.
So when
So
you
it'll
multiply,
become,
Yeah,
it'll become 4 times 3, which is 12, divided by 2 equals to 6.
okay, good. So what about the 4 though? Why did you do the 4 times the 3 and not the 4 times the 2?
Because it's like a denominator, so it has like
Yeah,
underrated 1.
yeah, because you can always look at 4 as being like 4/1, and then you just go straight across. So I just want to make sure, I mean, obviously, Dina, you understood that. I just want to make sure everyone else understands that. When you have a number by itself like 4, you can look at it as a fraction and then just go straight across. So that gave you your 12/2, but 12 divided by 2, that is just 6. Okay. All right, so let's see. Let's look at the, I'm not ready for that yet. So I need to talk to you about some definition here. Proper versus improper fractions. Versus, what do they call it? Mixed numbers. Ooh. Okay, so this is some language, okay? Proper versus improper fractions, and then these things called mixed numbers. Okay, so a proper fraction is a fraction like this, 3/4. And notice that with 3/4, the top, the numerator is smaller than the denominator. That is called a proper fraction. An improper fraction is when it's the other way around. The top or numerator is bigger than the denominator. So something like 12/, let's say 5. That's improper. And then a mixed number is something completely different that you saw in elementary school. And I'll show you how this works. Mixed numbers are another way of writing improper fractions. So if you have an improper fraction, you can also write it as a mixed number. And the way you do it, see, tell me if this looks familiar to you. If I take this, I do old school division, like back when you were in grade school. You put the 12 here inside the box, you put the 5 out here, and then you ask yourself, how many times does 5 go into 12? You say, oh, 2 times, and then 2 times 5 is 10. And then you subtract. 12 times minus 10 is 2, and this becomes your remainder. So then what you write next to this, now this is way old school, this you go 2 remainder 2. Remember writing that in like elementary school? 2 remainder 2. And then later they teach you, okay, don't write it like that, write it like 2, and that's this 2. And then you take the remainder 2 and you divide it by the 5 out here, 2 2/5. That's the mixed number version. So 12/5 can be rewritten as a mixed number as 2 2/5. Does anyone remember how to get from a mixed number back to an improper fraction? How do you get from here to here? Like if I give you a mixed number, how do you turn it into an improper fraction?
You change the 2 to match it, so it would be 5/5 and 5/5, and then you would add the top numbers.
So there is a way that you can do that by getting like I think like what you're referring to is like a common denominator. But a lot of times it's taught, there's like this shortcut that's weird. Not quite sure why you do it, but I'm going to do it and see if it rings a bell. Take the 2 and multiply times the 5, and then add this to it. So 2 times 5 is 10, right? And then you add 2. So what's 10 plus 2 is 12, right? So you put 12 and you put it over whatever this number here in green was. So you put that over 5. Let me do another one just to make sure y'all understand this. What if I had 3 and 1/4? What would that be written as an improper fraction? So 3 times 4 is 12. Add 1, it's 13. So I get 13 over what? 4. I saw Tiffany say that. Does that ring a bell? Cheyenne, does that look familiar now that I've done it? Okay. So going from an improper fraction to a mixed number requires that you do old school division back from grade school. To go from mixed numbers back to improper requires you do this little trick where you multiply, add, and then put it over the denominator here. In this class, you are going to see mixed numbers throughout the class. I recommend that you always convert your mixed numbers into improper fractions. I always recommend you switch them back. For example, what would 3 and 1/4 divided by 2 and 3/5 be? So we have an improper fraction. We have a mixed number divided by another mixed number. And what we'd like to do is first, we want to be able to do that keep dot flip, right? That keep dot flip that we looked at before with division of fractions. But we need them to be like fractions, improper fractions first. So I'm going to convert this first one over to an improper fraction. So I go 3 times 4 is 12. Add 1, that's 13 over 4. And then I'm going to divide that by 2 times 5 is 10. Add 3 is 13 over 5. Now that I've got it into nice fractions, I can do my keep dot flip. Y'all following me here? Keep dot flip now. So keep it, dot it, flip it, 5 on top, 13 on the bottom. And now at this point, because I have multiplication, right, I can go straight across. However, I'm seeing that 13 and 13 cancel. 13 goes into each of these one time. So now I can just multiply 1 times 5 and get 5 on top, and multiply 4 times 1 and get 4. So 5/4. We'll get more opportunities to practice that. Any questions? We ready for addition and subtraction? Okay, so again, when you're in grade school, you learn addition, subtraction first, and then you learn multiplication, division later. With fractions, we always start with multiplication, division, because addition and subtraction is harder. So let's talk about how we add fractions. Adding fractions. All right, so we have 2 cases. Case A, same denominator. Just to be clear, when you have a fraction, the top is called the numerator, the bottom is called the denominator. So if we have 2 fractions and we're trying to add them, we could have fractions that have the same denominator. And this is the easy case, okay? This is the easy one. Case A is the easy. So let me give you an example. 3/7 plus 2/7. So if you want to add 2 fractions together and they have the same denominators, they both have 7s here, all you do is add the tops together and keep the denominator the same. You do not add 7 and 7 together. So you get 3 plus 2 is 5 out of 7. So as a formula, okay, if you like formulas, here's what the formula looks like. A over B plus C over B. Notice they have the same denominator, right? They have the same denominator here. B. Then all you're going to do is take the A plus C and divide by the B. And that's it. Okay. Now, case B is the harder one. Case B. Not the same. Not the same denominator. So let's do an example. Let's do 3 over 7 plus 2 over 5. All right, so here's what we're going to do. In order to do this problem, we cannot do what we did up here because they do not have the same denominator. So what we're going to try and do is make them have the same denominator. And to do that, I have to convince you of something that you probably know is true, but I'm just going to convince you down here. Okay, recall, that means remember, that if you take a fraction, let's say 3 over 7, and multiply it times 1, that when you multiply anything times 1, it's itself, right? Any number times 1 should be the same number. Y'all agree with that? That's the property of 1. Now, the way that we write 1 can be any way we want. Like you can always write 1, like you could write it as, let's say 2 over 2. That would be 1, wouldn't it? And if we do this multiplication across, what would we get? 6 over 14. So what I'm saying to you is that these two things are equal. Because all I did was took 3/7 and multiplied it times 1. And I chose to put 2 over 2, but I could do anything. I could do, I don't know, 5 over 5 if I wanted to. And then if I multiply straight across, I get 15 over 35. And I'm saying to you that those are equal. These are all equal. These are all equal to 3/7. 15 over 35 is 3/7. 6 over 14 is 3/7. And of course, 3/7 is just 3/7. So anytime you have a fraction and you multiply it by times 1, it doesn't change it. It just makes it look different. So what we're going to do here is we are going to find what we call a common denominator. I know y'all have heard of this before. We're going to look at these two denominators, 7 and 5, and we're going to find what's called the LCD, least common denominator. All right, so what we need to do is find a number that is a multiple of both of these numbers. So it has to be a multiple of 7 and a multiple of 5. And all I mean by that is, list out the multiples of 7. 7 times 1 is 7. 7 times 2 is 14, 21, 28, 35, 42, 49. I could keep going forever, right? Those are all the multiples of 7. All the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, and I can keep going forever there. What we're trying to do is find a number, the smallest number that appears in both of these lists. And I think you can see it's 35. So again, that would be something that you have to mentally be okay with, the idea of finding common multiples of two numbers. So since they both have a multiple of 35, a multiple that's 35, what I need to do is try and make both of these denominators 35. So I'm going to look at this first fraction, 3 over 7. What would I have to multiply 7 by to get 35? What do you have to multiply 7 by to get 35?
5.
5. Okay, so here's what I'm going to do. I'm going to take 3 over 7, and I'm going to multiply it on the left-hand side. It doesn't matter which side I do. I'm going to multiply it by 5 over 5. And remember, that's a 1, right? 5 over 5 is 1. So I'm not changing what 3 over 7 is. I'm just going to make it look different. Then I'm going to take the 2 over 5, and I'm going to multiply that also by something. But to turn 5 into 35, I need to multiply it by 7 on the top and bottom. You'll see what I'm doing here? It's like I'm rewriting this to look like this, and I'm rewriting this to look like that. And now I do little multiplications on each one of these. So when I multiply straight across here, I'm running out of room. When I multiply straight across on this first fraction here, I get 15 over 35. And then when I multiply across here, I get 14 over 35. And now we can add these two because they have the same denominator. So now I'm back at case A. Same denominator, just add up the tops and put it over the denominator. So I should get 29 over 35. Let me give you another one. Are there any questions on that one? Give me another one. How about 3/4 plus 7/12? Okay, you're adding two fractions. They do not have the same denominator. So you can't just do the easy way. I need a common denominator, least common denominator. Can someone tell me what it is?
Is it 12?
It's 12, right? So what you could do is you could look at the two denominators, 4 and 12. You can start listing out their multiples, 4, 8, 12, 15, 18. Those, no, that's not right. 16, 20. Those are the multiples of 4, right? Then I can start listing out the multiples of 12, 12, 24, 36, keep going. And then find the smallest one on the list, on both lists, and that's 12. So you have to turn both of these into 12. One of them already is 12, so you don't have to do anything here. All you have to do is take this first one and multiply it times 3 over 3, because of course 3 times 4 is 12. So you go straight across on the top there, you get 9 over 12 plus 7 over 12. And now you can add across the top. 9 plus 7 is 16 over 12. Are we done? No, because that actually reduces. 4 goes into both of those. 4 goes into that 4 times, 4 goes into that 3 times, so you get 4 over 3. Okay, is there a formula for this? I mean, I told you here a second ago, in the easy case, there's a formula, right? Is there a formula for adding two fractions that don't have the same denominators? What do y'all think? Would you like there to be a formula? There is. Okay, there is a formula. I'll give it to you right now. If you have A over B plus C over D, okay, and you want to add two fractions together, if you don't want to have to think too hard about what to do, was there a question? No? Here it is. You ready? It's A times D plus B times C all over B times D. Now that formula may be something you look at and you're like, well, I'm never going to remember that. Okay. There is actually kind of an easy way to remember it once you kind of pick up on it. Here's what it is. You see this A times D, that right there? That's multiplying those two together. This top one, this bottom one. Then you have the plus sign. Then B times C are those two multiplied together. And then the B times D are those two multiplied together. So let's see if we can't do that for the problem we just did before. 3 over 4 plus 7 over 12. Let's see if we can't use this shortcut. So what I'm going to do first is I'll multiply 3 times 12, and that gives me 36. Then I say plus, now I add to that 4 times 7, which is 28. And then I divide all of that by the 4 times 12, which is 48. Y'all see what I did there? 3 times 12, 36, 4 times 7, 28, 4 times 12, 48. And then I add these two together. What is that? 50, 64 over 48. And this is correct, but we have to reduce it. So there's something that goes into both of these. What goes into both of those?
Is it 12?
I think it's 12. Yeah. So if you don't see that it's 12, one thing you could do is just start with something smaller. Like they're both even. So I could say, okay, 2 goes into that, right? 2 goes into that 32 times. And 2 goes into that like 24 times. And then these are both even again. So I could try 2 again. 2 goes into there 16 times. 2 goes into there 12 times. And then 2 goes in again. So 2 goes into there 8 times. 2 goes in there 6 times. And look, 2 goes again. So it goes in there 4 times and then 3 times. So you should get 4/3 at the end. Same answer. So if you like formulas, here you go. Now, the big drawback to that formula, okay, I'll just be honest about it. It's a nice formula and you'll see me use it. The drawback is that you're usually going to get big numbers. And so the reducing can be a little complicated, just as a warning to you. But it works for any time you want to add fractions. If we want to go back to this example right here, remember we got 29 over 35. If we were to do that shortcut, 3 over 7 plus 2 over 5. So we just multiply 3 times 5, that's 15, plus 7 times 2, that's 14, over 7 times 5 is 35. We will get exactly 29 over 35. So you can do it without actually having to think about multiples and all that stuff. It's just a very mechanical process. All right, y'all doing all right? Think about it this way. We only have to meet 16 times. It's maybe a positive way of looking at it. 8 weeks. All right. So what about subtraction of fractions? What about subtraction? There's good news for subtraction. The only difference with subtraction is that you put a minus sign in here instead of a plus. So you see this formula I had here? If we just change that plus to a, if we change that plus to a minus, then that becomes a minus right there. That's it. And same with that shortcut formula here. If we do minus here, there's a minus there. So let me do an example of subtraction. I'll do 2 examples. Oh, and I'm going to go quick here. 1/2 minus 3/4. And let's do, oh no, 1/2 minus 3/2. We'll do same denominator. And then we'll do 1/2 minus 5/6. Those have different denominators. Okay, these two have the same denominator, right? So all we have to do is take the top and do 1, subtract 3, 1 minus 3 over 2, keep the denominator the same. What's 1 take away 3? Ooh, this is where things start getting weird for people. What's 1 take away 3?
2.
-2, right? -2 over 2. And -2 divided by 2, these are the same numbers, so these turn into a 1, but you have a negative in front, so you get -1.
I have a question.
Yes.
Not to say this in a weird way, but I thought it was like illegal to have a fraction and put like a negative number in the numerator.
Illegal to put a fraction.
Like people are always telling us not to do that, or at least with me.
Who told you that? No, I'm kidding.
I
Yeah, so look, this is actually, you're bringing up something very good. I was about to talk about this. Can I do the next one and then we'll address your question?
Oh, yeah.
Okay, let's do that. Okay, so for this one, do y'all want to find a common denominator and do the multiple list and do that? Or do you want to do the shortcut? What do y'all think? First one who responds, that's the way we're doing it. Well, you know what? Short, okay, I was gonna ask, we'll do it the way, I'm gonna say this right. Is it Darshili? Darshili?
Darshil.
Darshil? Shiel. Shiel.
Shell.
Shell.
Yeah.
Darshel. Okay. Darshel, do you want to do the shortcut or do you want to do a common denominator? We'll let you decide for this one here. Oh, you can't hear me? No? Can everyone else hear me? No? Yeah, I can't hear you. I'll come back to you. I'll count you as being here. You're good. Bonnie, is Bonnie here?
Yes, I'm here.
Okay, Bonnie, I'll let you decide then, Bonnie. Do you want the common denominator or do you do the shortcut? It's up to you. You're muted still.
My bad. The common denominator.
You want to do common? That's the way you like to do it? Okay, so can you tell me what the common denominator here would be?
It would be 6.
6. So that means you have to multiply this first fraction by 3/3. Yeah? Okay, so that would give you 3/6 minus 5/6. And now again, we're going to have to do 3 take away 5. And then keep the denominator the same. 3 take away 5, we get -2 again, and then over 6. And that reduces because 2 goes into 2 once and 2 goes into 6 3 times. So we get -1/3. And this brings us back to, is it Bela? Am I saying that right? Bela? This comes back to Bela's question. Can you have a negative up top on a fraction or something to that effect? Okay, so let me tell you what when it comes down to fractions in negative signs, this is really important. If I write -1/3, that is the same as writing 1/-3, but that is the same as writing -1/3. All three of these are equal. So to get to Bela's question, when you have a negative on a fraction, the negative can be on the top, or if you'd like, you can move the negative to the bottom, or if you'd like, you can move the negative out front. It's your choice where to put it. Always your choice. You have to be careful though. If you have a negative, let's say we do a problem and we get a negative on top and a negative on the bottom, negative on both top and bottom, right? Then the negatives cancel and you get a positive because a negative divided by a negative is positive. So 2 negatives will wipe each other out and become a plus. But if you have 1 negative, it's top or bottom or out front, you get to decide. Bela, does that address your question or concern?
Yes,
Okay,
it does.
good. You're going to see me use this property later. Okay, so in theory, we've now seen how to multiply 2 fractions, divide 2 fractions, keep dot flip, right? So multiply straight across, divide, keep dot flip, multiply, add and subtract. You have to look, do they have the same denominator? If they do, great. If they don't, we have 2 different ways. We can do shortcut or we can do the way we did here. So now, what are we going to do next? Well, let's look at the homework. Let's look at the homework so far, page 221. You should be able to handle all these homework problems. Now notice some of them are mixed numbers. So like on number 2, you'd have to convert that into improper fractions first and then do the arithmetic. But everything here should be doable, all right? Now pay attention. Well, no, I'll keep there, never mind. So notice on the homework, you start out with just stuff we've been doing, right? That should be all good. And then all of a sudden we get to word problems. Oh my goodness, word problems, word problems. Okay, so let's do this. I am going to go back to the notes here. Here we go. I'm going to leave these problems up here. I want you to look at 18, 19, and 20. And I'm going to give you, let's say, 5 minutes to 6 minutes to see how far you can get on these word problems. I'm not going to help you with them right now. I just want to see where everyone is here. And I'm going to call on someone after about 6 minutes from now. I'm going to call on someone and we're going to see if we can get through these 3 problems together as a class. I'll give you a hint. All 3 of these problems are going to have fractions and somehow either going to have addition, subtraction, multiplication, or division involved. It just depends on the problem. You have to read it. You have to try and understand it. And I'll give you one piece of advice before you start these. The thing that causes the most problems on word problems with fractions is the fractions themselves. For some reason, they make people freak out. So if you're having trouble understanding what to do, I recommend that you maybe rethink the problem by replacing these with like easier numbers. And like just simple numbers like that you hear every day. And maybe if you look at it that way, you might be able to understand what operation you're supposed to use to do the problem. Maybe not, but we'll see. I'm going to let you go. So let's go 6 minutes from now, 7 minutes, maybe 12:50, we'll talk. Okay. I would normally do a breakout room right now. This would be where I would do breakout rooms, but not every one of you have downloaded the packet yet and have it available electronically. So in the future, download the packet or have it with you. That way, if I put you in breakout rooms, you don't have to copy these problems down. You have them there with you. All right. Okay. Enjoy. I'm calling on somebody in a minute, a couple of minutes. Hey, everyone, the most important thing here is for you to be able to set up these problems. I don't necessarily care about you calculating the answers. I want to make sure you know what the operation is for each one. Like, is it addition? Is it multiplication? Is it division? I added another one there in case you got the first three. Okay, everyone, I think that's enough time for at least the first few. Just FYI, while you were doing that in the chat, I sent everyone a link to a Dropbox. And I also emailed it to you in Canvas. That is where you can practice sending me like a couple of pages of work or something into a single PDF. Maybe like what you did today in class, like anything you wrote down or whatever you want. Just make sure that you do, don't just send me a single page of work. Do something that shows me that you have the ability to take multiple pages and turn it into one PDF file. So let's say try and get that done by next class, and that way I can make sure you know what you're doing. Okay, we're ready. Let's see. We're gonna start with Layla. Layla here.
Yes. For number 18?
Yeah, you know what, Layla, on the roster, it's Layla, and then on your screen, it's Bayla.
It is. It is. I go by both. They're not too far off. I'll respond to anything, either one.
Okay, what do you prefer? Because I can just change it right here into Bayla. Is that easier for you? Okay,
Yeah,
I'll go Bayla. All right, so Bayla, all right, you're up. All right, so first one, what are you thinking on the first one?
So it's definitely adding. I wrote it out in my textbook. I lined it up so that it was 2 1/4 plus 5 3/4. And this one will be a little easier because the denominators are the same. So you don't have to change anything. So you can add the fraction, which comes out to like 4/4, which is one whole number. So you have the 2 plus the 5 plus the now fractions that are a whole pound.
Yeah, so what Bela's doing here is probably the way that you learned how to add mixed numbers back in some previous class or time of your life. And that is to line them up vertically like this. Do you all recognize this? Yes, maybe not. Okay, and this will work. Now, I have to warn you that things get complicated if this were subtraction, and this becomes very dangerous, right? So like if this were subtraction, then you would be doing 1/4 take away 3/4. That would give you a negative number, and that's going to cause problems. So Bela, even though you want to do this, and I'm okay with you doing it, it's at your own risk, and it depends on how comfortable you are with that. My recommendation for this problem would be to take the 2/4, convert it to an improper fraction. That becomes 9/4. I got that by doing 2 times 4. Where's my cursor? My cursor's gone. Where is it? Oh, my cursor does not want to come up on here for some reason. That's weird. Okay, so I did that thing where I did the 2 times the 4 plus 1 and got 9, and then put it over 4, and then I'm going to add to that. Same thing here on this one. I do 5 times 4. There it is. Now my cursor's here. 5 times 4 is 20. I add 3, I get 23 over 4, and that gives me 2 fractions with the same denominator. When I add those, I do 9 plus 23 over 4. This is 32 over 4. And if 4 goes into 32, then I can get an answer. Does 4 go into 32? It does, right? 8 times?
Yes.
You get an answer of 8. Which is the same answer Bela would have got the method she's using. But again, just be careful, okay? Now, I didn't talk about why it's addition. That Bela said it's addition, so that's what I did. Now I agree, but let's see why. Dolores sold candy by the pound. First person bought so much. The second person bought another amount. How many did she sell total? So you're trying to figure out the total pounds that were sold. So you just add the 2 together. I think that's a straightforward one. Does anyone have any questions over that? How about the second one? Let's see, Juliet. Is it Juliet? You getting that right? Okay, Juliet, you're up. So did you have any thoughts on the second one? Have any trouble with it or?
Yeah, I'm pretty sure it's division.
Okay, good. Now, we have to be real careful with subtraction and division. Subtraction and division are the only 2 operations where order matters. So for example, if I tell you, this is not to do with this problem. If I said, hey, everyone, what's 2 minus 5 versus 5 minus 2? Those give you 2 different answers, don't they? The order of that matters. Same with division. If I say, hey, take 2 and divide it by 5 versus the other way around, 5 divided by 2, those give you 2 different answers. Addition and subtraction, addition and multiplication, the order does not matter, but division, subtraction, it does. So, Juliet, you say it's division, what's being divided by what, or what's the order you did?
44 divided by 5 1/2.
44 divided by 5 1/2. That is correct. Now, Juliet, when you did this, did you have any problems figuring out that it was going to be division? Or was it clear to you?
I was pretty clear because
It's pretty clear.
Yeah, how it asked it.
Okay, yeah. So remember when I said if you're having trouble to make the numbers something easier. So like if you change this to like 5, and let's just change that to, I don't know, 20, and we read the problem. You know, language arts class was assigned to write a team paper. Each team was to write 5 pages. When all the teams put theirs together, it was a total of 20. How many teams worked on the paper? So if you had 20 pages and there were 5 pages from each team, then you got to figure out how many times 5 goes into 20. So you have to take 20 and divide it by 5, right? That is the work that you have to do mentally to deduce that. Now, if you do 5 divided by 20, that's incorrect. because you're not trying to figure out how many times 20 goes into 5. You're trying to figure out how many times 5 goes into 20. So this is correct. Juliet has set that up correctly. Now, did you actually do it?
No, I didn't fully solve
Okay,
it.
you got it set up though, right?
Yeah.
So now to do this, what I would do is take the 41, put it over 1, make it into a fraction, divide that by. Now I would convert the 5 1/2 over to a improper fraction by multiplying 5 times 2 and adding 1. So 5 times 2, add 1. That's 11 over 2. You with me? Everyone with me on that? And now do your keep dot flip. Keep dot flip. And then from there you can multiply straight across and reduce the fraction. Or you could reduce it right now if you realize that 11 goes into 11 once and 11 goes into 44 4 times. And then if you multiply straight across, you should get 8, which just so happens to be the same answer as the previous problem, just coincidentally. I just want to let everyone know that at any moment I could get someone at my door that I need to take care of. Getting some stuff hauled off from my backyard, and I have to put my dogs away. So just FYI, it'll take 2 minutes once it happens. Okay, good. Let's see, Tiffany. I don't think I called on Tiffany yet. Is Tiffany here? How's it going?
Good, how are you?
Good, we can hear you, good. All right, so Tiffany, how about the 20? Did you get to number 20?
Yes, for 20 I had subtraction.
You had subtraction. Okay, so let's read this. Dennis's new dog weighs 127 3/4 pounds. His friend's dog weighs this much. How much more does Dennis's dog weigh? So you did subtraction, which order matters, right? So what did you do? What minus what?
I did 127 3/4 minus 94 1/2. And I just made sure that both fractions had the same denominator.
Okay, so did you convert these into improper? Did you leave them? How did you?
Let me check, sorry. I did it all on my phone. No, I didn't convert them to improper fractions. I just did it as is.
Okay, so that will be okay. This is kind of like Dayla's way, the way that she was saying. Basically, you did 127, you subtracted 94 and got a number, and then you did 3/4 and subtract a half, something like that, right? Okay, I'm going to leave that to everyone to figure out. You know, everyone's going to get a different answer, and at some point, we're going to wind up putting our answers in decimals anyway, so we're not going to care. The main thing on this is the setup, so that is correct. Good. Okay, anybody do 21? Anyone get to 21 yet?
I tried, I couldn't figure it out.
Oh, okay, let's read through 21. This will be the last one from this section. Okay, on their vacation trip last summer, the Pace family got 31.5 miles per gallon of fuel on their trip from home. On the return trip, they only got 17 7/8 miles per gallon. How many more miles per gallon of fuel did they get on their way out than on their way home? So maybe again, the numbers are confusing. Let's say that's 30, and let's just say that that's 18. So they got 30 miles per gallon on their way out, right, when they went out for their trip, and then they got 18 miles per gallon on their way home. How many more miles per gallon of fuel did they get on their way out? So we want to know the difference between these two, don't we? We want to know what's 30, take away 18, and that would give us, in this particular case, 12. That would be the difference. We want to do the same thing, but we want to use the numbers that they gave us, which are 30.5. Take away the 17 7/8. So the way I would do this, again, I would convert this into 61/2. So what I'm doing there is I'm multiplying. Come on, it's weird that sometimes my cursor disappears, sometimes it doesn't. So So I did 30 times 2, which is 60, and I added 1 and got 61 over 2. Now I'm going to do 17 times 8. So that I'm probably going to need a calculator for. You might need a calculator for. That's 80 plus 56. I think that's 136. And then you add 7 to that. So 143 over 8, I believe. I'll double check it. I don't want to give you incorrect information here. Yeah, 143 over 8. And then at this point, we have 2 fractions being subtracted. So we could use, I think, Bonnie's method to get a common denominator here. Or we could do the shortcut where you do the like multiply, multiply, multiply across the bottom. That would be kind of up to you how you want to do that. So I'm going to leave this again as to be continued by you. If you wanted to. In your homework, you'll do your own problems, but okay, it's 103. Let's move on. The word problems are just things you're going to have to mess with. So here's again your homework assignment. And so it starts in the packet on page 221. Work through these problems. Get as much done as you can on the word problems. I'm guessing that when we meet again, somebody's going to have a question over one of these word problems. So I'll start class next time by seeing if anyone has any questions on this. All right. But we need to move on to order of operations now. So we are starting a new topic, order of operations. And I'd like to start this out with a problem for you to try. All right. $16, that's a divided by 4 times 2. All right, I'm going to give you 30 seconds to a minute. And while you're doing that, I'm going to do a poll. I think I can do a poll. Where is it? Where's my poll? Oh, there it is. So you may not be able to get this poll depending on what kind of device you're using, but I just launched the poll. And don't answer it yet. We'll answer the question in a second. Everyone just try and work out 16 divided by 4 times 2. All ready? I'll give you enough time there. 16 divided by 4 times 2. Now, I'm going to give you 2 options, and you answer on the poll. If you answer yes, then you think that the answer is 8. And if you answer no, then you think that the answer is 2. So yes for 8 and no for 2. So I've had half of you respond so far. 79 of you. There's 12 people here. Interesting results here. Anyone else? Okay. There's one more person. Let's see if they're here. Maybe they've stepped away, but it might be, I think someone's having trouble with their audio right now. So, okay, you ready? I'm going to end the poll and I'll share the results. I'm not sure what you see on your end, if you can see the results of that poll.
We can.
Okay, so it looks like about 2/3 of you, 64%, think that the answer is 8, and 36% of you, 4 of you, think that the answer is 2. So I think it's pretty easy to show why the 64% think it's 8. The people who think it's 8, I think what they're doing is this. They're doing 16 divided by 4 first, right? That's what? 4. And then they do times 2, which will give you 8. Right? And then the people who think it's 2 are doing something different. They're doing what, the 4 times 2 first and getting 8. And then they still have the 16 and they have to divide that by 8, which gives them 2. So the question is, which is the correct answer? They can't both be right. That's not the way math works. Because if math worked this way, where one person can get one answer, another person gets another answer, you could never build a bridge or a plane or anything, because engineers would be getting different answers depending on how they decided to do it. There has to be some order of operations that we all agree upon, and that way we don't get different answers. Okay, so that's what order of operations is all about, is us all agreeing, us meaning human beings, need to all agree upon the order in which we do things. So the order that we use is this thing, you may have seen this before, this thing, Pemdas. Have y'all seen that before, Pemdas? It basically lists out the order in which we do things. The first thing, P stands for parentheses. I'm just going to put para for parentheses. Then we do exponents. That's where you have things raised to powers. Then multiplication, division. This is what the letters stand for: division, addition, and subtraction. That's your order of operations, right? Now, if you learn Pemdas, that's great. The problem is Pemdas can be used incorrectly. So the correct answer here, the correct answer is, well, 64% of you think it's 8 and 36% of you think it's 2, right? So the correct answer here is 8. Now, why? Because if you look at Pemdas, parentheses, well, we don't have any parentheses, okay, so we don't need that. Exponents, we don't have any, okay. Now, if according to Pemdas, I'm supposed to do multiplication first, right? Which would mean we do this way, right? So the people who got this answer of 2, they're just following Pemdas. Multiplication goes first, we multiply those, we get 8, and then we do the division next, 16 divided by 8, and you get 2. So why is that wrong? So can somebody that said it's 8 explain why you did division before the multiplication?
Because multiplication and division are interchangeable within Pemdas, and depending on which one is first in the equation is which one you do first.
Exactly. So when you're taught Pemdas, multiplication, division, it's never multiplication before division. They're equal, okay? We treat them equally. It's just the order we do them is the order in which they appear as we would read like a book from left to right. So you have to do, when you see that you have multiplication and division, multiplication doesn't get priority. It's from left to right as you read it like a book. So I would need to do the division first to get the 4 and then the times 2. And addition and subtraction work the same way. This is from left to right. And this is also from left to right. So I can remember being in college. I'm a math major, right? Like when I started college, I wasn't a math major. I was an architecture major. But I remember that when I was in a class and I was given a problem like this, I was pissed off because when I was taught Pemdas, I was taught it incorrectly. And I was told multiplication goes before division. Now, it could be that I was taught correctly. I just understood it incorrectly. But I'm pretty sure my teacher told me multiplication before division, and that's incorrect. So if you got the answer here of 2, okay, which is incorrect, it's not your fault. It's now you've learned something. Multiplication, division are equal, always left to right, okay? Now, that was just to illustrate how important it is that we understand order of operations, because you don't want to get 2 different answers that are, right? 2 answers, 2 different answers, 2 different engineers working on a problem, get 2 different answers. Nothing would ever make sense. So let's work through some of these problems. These are rather complicated to start off here. I'm going to just copy some of these and take them to a new page. All right. So let's start with number one. All right. With number one, I look at this, I'm thinking Pemdas. Multiplication, division are equal, addition, subtractions equal. All right, so when I look at this, I see subtraction, addition, 72, and then a parentheses. What's the operation? What's the implied operation right there? Even though the nothing is there, what's implied? That's
Multiplication.
It's multiplication. This is 72 times, so I'm going to use a dot for the multiplication. So I have subtraction, addition, multiplication, then I have a parenthesis, and inside the parenthesis I have subtraction. So what am I going to do first? Well, everything in parentheses. I have to do everything in the parentheses first. So I'm going to take 10 and subtract 2. So when I take 10 and subtract 2, it becomes 5, take away 3, plus 72 times 10 minus 2 is 8. So I've taken care of parentheses. Now I'm going to just look at these, subtract, add, multiply. I have to do the multiplication first. So my next line is going to be 5, take away 3, add to it. What is 72 times 8? Well, again, you got your calculator handy because we don't want to be making mistakes on arithmetic. 576. What comes next? I have subtraction and addition. Which one goes first?
Subtraction.
Subtract, because I'm going to read from left to right now. So 5 take away 3 is 2. Plus 576 is 578. All right, what about this one? That's really complicated looking, isn't it? See if we can do this one. All right, so I have a whole, there's just like a ton of stuff happening here. I've got several sets of parentheses, and then within certain parentheses, I have other parentheses. So I have this set of parentheses, I've got this set of parentheses, and inside that, I've got that set of parentheses. I've got exponents, right? Things being raised to powers. This really could become a disaster. But I'm just going to kind of take this piece by piece. I'm going to start with the innermost parentheses I see, which is the green parentheses. I'm going to just start there. I'm not going to touch anything else. And it's going to kind of suck because I'm going to have to write a bunch of stuff down. Okay, what is 1 take away 4? So if you have 1 take away 4, what do you get?
-3.
-3. So I'm going to write here -3, but I still have the squared. Now, when I say squared, I'm talking about this one right there, right? And then I still have another parenthesis and then another squared. Now the million-dollar question. What's -3 squared? So what's -3 squared? Well, you know what? Yeah, let's do that. Let's pause on that. Let's pause. Let's continue. Let's do our order of operations. Let's continue working it. I need to do what's in parentheses, right? I've got this set of parentheses. I've got this set of parentheses. So I still have this. I still have this, right? Let's work out what's in the yellow here. Okay, 3 take away 6 is -3. Y'all agree with that? Is that correct for me to write that this way? 2 plus 2, and then since this turned into -3, I'm just going to put -3. What's wrong? I see you shaking your head.
Oh, it's because what you do is you got -3 right, but because of the parentheses, you would multiply whatever's in the parentheses by the 2.
That's right. So that means I need to leave that -3 in parentheses here so that I can actually do this multiplication operation. It's not 2 minus 3, it's 2 times -3. Okay, that can be a little tricky. Let's keep moving here. I've got this parenthesis here, squared. Let's work out what's in here. So when I'm looking at what's in this parenthesis here, I'm going to do this exponent first. So now I can ask, what is -3 squared? Doesn't that mean -3 times -3? Doesn't that give you 2 negatives multiplied to be positive? Right, so you get +9 there. So I'm going to get 1 plus 9. And then all of that will be squared. So my next line, I'm going to do what's in that parenthesis. I'm not multiplying that yet. 1 plus 9 is 10. So put those together, get that. Then I'm going to square the 10, because exponents come next. 10 squared is 100. So I'm going to go minus 100. Now I have multiplication, so I'm going to do the 2. What is 2 times -3? A positive times a negative gives you negative, right? Yes. So -6, and we still have minus 100. Then I do 2 take away 6, that's -4. Take away 100, and that gives you -104. Okay, so look, we have a lot to do here still. Okay, when it comes to order of operations, there are a lot of problems that we still need to work through. I think what would be best is if I clarify a few of the symbols here, just to make sure you understand what they are. And then I let you work some of these and then ask me questions if you're not getting the correct answer. Because again, everyone's kind of at a different level with the order of operations. So let me just clarify a few things. When you see these bars, those bars mean absolute value. So if you're not familiar with absolute value, just to remind you, the absolute value of like a negative number always spits out that number but positive. So that's what the absolute value does. It just turns whatever's inside of it into a positive number. So the absolute value of -4 would be +4. The absolute value of +4 would also be +4. So it just takes whatever in here and just removes any negative signs from it. Just spits out positive. Okay, so that's the absolute value. So you may see that appear in here. And then also you may see the square root symbol. So if you take like the square root of 9, that just means you have to figure out what number times itself gives you 9. So this would be 3. Another example, square root of 16 would be 4. Another example, square root of 25 would be 5. Another example, square root of 10 would be, who knows? It's not a number that we can think of in our head. So that would be something that you would just, stay tuned. That'll come later. We'll talk about that. But these 3 should be okay. Other than that, everything else here is just arithmetic. So what I'd like to see you do, because we have 20 minutes left, and I don't want to get into the solving equations for homework. What I'd like for you to try is page 225. Just try and see how far you can get with the first 15 problems. And then again, I think that you'll probably have some questions next time. Questions on word problems and on those. So go to our schedule here. So all you're doing for homework tonight is this whole section. And then this, you're just going to do 1 through 15. And so we're a little bit behind today, which is okay because it's the first day. Next time we're just going to pick up and go. But I never gave y'all a break today, did I? I just kept going through. So I'm going to end about 10 minutes early, which means I have another 8 minutes still. Does anyone have any questions at this point?
I have a question about the absolute value.
Yes.
Would that fall under just subtraction, or do we do that first as a parentheses, or?
Oh, very good. Absolute value would be treated as a parentheses.
Okay.
Very good question. Yes. Same with the square root. The square root, like right here, let me give you this example right here. That square root symbol means that you do everything inside of it first. So figure out what all of that is equal to first, and then after you're done, take the square root of it. So you could look at that problem as being like this, actually. That makes sense? Do all of this, and then when you're done, take the square root. Okay, so because today's the first day, I wanted to just show you something mathematically. I'll try and do this every once in a while, just it's kind of like random useless information, but maybe you'll find it interesting, and it's a break from this monotonous like math that seems like it's for no purpose. Okay, so I'm going to tell you a quick little story. I've got 7 minutes to do it. There's a famous mathematician. His last name is Gauss. And there's a very famous story about this mathematician. He lived in the 1800s. And the story goes as follows. He was in kindergarten. Okay, so he was in kindergarten, and this is back in the 1800s. He went to kindergarten, and back then they used to write on. They didn't have paper readily available like we do. They would in class they would write on these little chalkboards, these little slate tablets. And so the teacher went into class on this particular day and gave his students a problem. So imagine you're in kindergarten, right? And the teacher says, "Hey class, what's 1 + 2 + 3?" So these little kindergartners are like, right on their little slate tablets, and somebody raises their hand and they're like, "Oh, the answer is 6, right?" Okay, good. So the teacher said, "Okay, what's 1 + 2 + 3 + 4?" And so they mess around with that and they add it up and they get 10. You get the idea here? Next thing the teacher asked was, "What's 1 + 2 + 3 + 4 + 5?" And they said 15, right? These are kindergartners, all right, and they're doing this. So the teacher says, "Okay, now here's what I'd like for you to do now, class. I'd like for you to do 1 + 2 + 3 all the way out to 100. So 1 + 2 + 3 + 4 all the way out to 100. And the students sat there and started working it out. And the story goes that within a few minutes, okay, Gauss took his little slate, turned it over, which is what they used to do as a sign of "I'm done." He turned over his slate and sat there nice and quiet, arms crossed, and just waited for the teacher. The teacher came and turned over Gauss's slate, and this is what Gauss had written down: n times n + 1 / 2. And the teacher looked at that and was like, "What?" Well, the way this formula works is if you take the last number and call that n, okay, so look at this. Let's say n is 3. Plug 3 into this and let's see what happens. 3 + 1 / 2. You get 3 times 4 / 2, which gives you 12 / 2, which is 6, which is the answer. This formula works for any, like if you plug 4 in here, you're going to get 10. If you plug 5 in here, you're going to get 15. If you plug 100 into this formula, it's going to give you what this adds up to be. So the interesting question is, how the hell did someone in kindergarten come up with this formula, right? How did he do it? So unfortunately, I was about to show it to you, but I just got the people that showed up. So I'm going to leave this as the first thing I'll start class with next time. Okay, how did Gauss come up with this formula? And what you're going to figure, once I show it to you, what you're going to realize is that it's not that big of a stretch that he was able to come up with this. Like, I'm going to show it to you, and I think a lot of you are going to be like, I see that. The thing is, he was in kindergarten, okay? And it's the genius. The fact that it's easier than it looks is what made him a genius. But I'll share that with you next time. It's a pleasure meeting everyone. I will see you all on Wednesday. Have a good rest of your day and tomorrow. And if you have any questions, just email me. Okay?
Thank
Bye,
you.
everyone. All right, thanks.
Thank
Have a
you. Bye, everyone.